Hello guys, welcome back to a new video. In this video we'll be solving practice 3C. Now the Mariana Trench in the Pacific Ocean, question 1, is about 11 kilometers deep. Okay, now you have what? As you know, you have height, okay, here. Then it says if the atmospheric pressure at the sea level is 1.01 times 10 to the power of 5, this is atmospheric pressure, how much pressure would a submarine need to be able to withstand to reach this depth? Write the givens as usual. So you have height, which is equal to 11 kilometer. Then atmospheric pressure, as you remember, P note is equal to 1.01 times 10 to the power of 5 Pascal. How much pressure would a submarine need to be able to withstand? So it needs what? It needs absolute pressure. Okay, absolute pressure is equal to, absolute pressure is equal to what? You can just simply write P, or just P alone is okay too. So you can say P is equal to P note plus rho G H. Now guys, let's take a look at the givens we have. Do I have the atmospheric pressure? Yes, it is here. Do I have density? It's the density of what, guys? It says Pacific Ocean. So you know that the density is equal to what? Density of the seawater is equal to 1.025 times 10 to the power of 3 kilogram per cubic meter. Okay, this is the density. Now I have density 2. Do I have gravity? Yes, guys, gravity is equal to 9.81 meter per second squared. Okay, do I have the height? Yes, I have the height too, which is equal to 11 kilometer. Just plug in the values that you have and calculate the pressure of the submarine. Now you have what? You have 1 point, so P is equal to 1.01 times 10 to the power of 5 plus density of the seawater is equal to 1.025, or you can put this in parentheses, times 10 to the power of 3 times gravity is equal to 9.81 times height is equal to 11 kilometer. So calculate all of this and you will get 1.11 times 10 to the power of 8 Pascal. This is question 1. Question 2, it says a container is filled with water to a depth of 20 centimeters. So you have a container, 20% of it, so let's say this is 20%, 20 centimeter of it is what? Is water. Okay, so this is water. On top of the surface, on top of the water floats a 30 centimeter thick layer of oil. So on top of this, guys, you have what? Oh, let's just use this one. You have what? You have oil, okay? On top of this water, you have a 30 centimeter. So this is 30 centimeter. 30 centimeter, you have a thick layer of a centimeter of 30 centimeters oil, okay, with a density of 0.7 times 10 to the power of 3 kilogram per meter cube. It says what? It says what is the pressure at the surface of the water. First of all, let's write the givens that we have, then we will solve the question. You have H, which is height of what? Height of the oil. So you can say height of oil is equal to 30 centimeter, okay? Because you have meter here and all of your units are in kilogram, you should change this to meter. So this one will be 0.3 meter. Or you can just simply say 30 times 10 to the power of minus 2 meter, which is the same. Then you have height of the of water, which is equal to height of water. Let's just say HW is equal to 20 centimeters, and this one is equal to 0.2 meters, okay? Then guys, you have what? You have density of oil, which is equal to 0.70 or 0.7 times 10 to the power of 3 kilogram per cubic meter. Okay. Then it says what? It says what is the pressure A? It says the pressure at the surface of the water. Okay. Now guys, you know that this is the surface of the water. At the surface of the water, guys, you have what? You have oil. Okay. So you should use this height and calculate the pressure of the oil that it's exerting on water, and you'll also calculate what? You'll also calculate P naught. Okay, so you need what? You need atmospheric pressure too, which is equal to 1.01 times 10 to the power of 5. Okay, Pascal. So the pressure that the oil is exerting, so it says, guys, careful, it says the pressure at the surface of the water. As you know, you have a 30 centimeter thick layer of oil on top of water. It's exerting the pressure on the oil, and you also have what? You also have P naught, which is the atmospheric pressure, which is also exerting a pressure on top of the surface of the water. So you can write this like this. You'll say P is equal to pressure is equal to P naught plus rho G H. Rho of what? Of oil. Careful, this is the oil's part. Okay, oil. Then you'll say what? You'll say this is equal to 1.01 times 10 to the power of 5 plus, in parentheses, you have density of oil, which is equal to 0.7 times 10 to the power of 3. You have gravity as usual, you have what? 9.81. You have height of the oil. Careful, you are going to use height of the oil, which is equal to 0.3 meter. Then times 0.3, okay? You're not going to use this one because you are dealing with oil. It says on the surface of the water, careful. So calculate all of this, and you will get what? You will get P, which is equal to 1.0306 times 10 to the power of 5 Pascal. Okay, this is the absolute pressure or the pressure at the surface of the water. B, it says what, guys? What is the absolute pressure at the bottom of the container? So guys, this is the bottom of the container, okay? And you have what here? You have water. So we found the pressure here, which the oil is exerting, with the P naught. So you have this one, all of it together is applying a pressure first. Then we will calculate what? We will calculate the pressure inside the water too. So you can easily guess. You have what? B. B. It says pressure inside the water. So guys, look, you have what? You have the givens. Let's write them again. Height of water is equal to 0.2 meter. Okay. Then you have rho naught, or the absolute pressure, or you can say this is let's just say pressure of the let's just call it O, okay, which is this pressure. Careful, it's this pressure on top of the surface of the water. We found it, and it's equal to 1.0306 times 10 to the power of 5, okay, Pascal. Then you have what, guys? You have the density of water. This time you're going to use the density of water, which is equal to 1 times 10 to the power of 3 kilogram per cubic meter. Then you have what, guys? It says find the absolute pressure. So absolute pressure will be what, guys? Will be P naught plus rho GH. Then we found rho P naught, which is equal to 1.0306 times 10 to the power of 5 plus density of water, all in parentheses, 1 times 10 to the power of 3 times gravity is equal to 9.81. Then you have height of the water, which is equal to 0.2. Then calculate all of this. You will get 1.05 times 10 to the power of 5 Pascal. Okay, this is the pressure at the bottom of the water. A beaker containing mercury is placed inside a vacuum chamber in a laboratory. The pressure at the bottom of the beaker is 2.7 times 10 to the power of 4. What is the height of the mercury in the beaker? Now guys, as usual, write the givens that you have. you have what here? You have the pressure at the bottom of the container, so it's already given, okay? You don't have to find absolute pressure. Absolute pressure, or pressure, is equal to 2.7 times 10 to the power of 4 Pascal, okay? This is the pressure at the bottom of the container, okay? You have mercury, you have a beaker which is containing mercury, and its pressure at the bottom of the beaker is equal to 2.7 times 10 to the power of 4. What is the height of the mercury? It says H is equal to what? Okay, now guys, look, you will say pressure is equal to atmospheric pressure plus rho GH. Now guys, let's take a look. Do I have this one? Yes, I have. Do I have atmospheric pressure? Yes, atmospheric pressure is equal to what? It is equal to we don't have atmospheric pressure, okay? I'll talk about this one in a minute. Do we have density? Yes, we have density of mercury. Density of mercury, let's just write M is equal to 13.6 times 10 to the power of 3 kilogram per meter cube, okay? Then, do I have G? Yes, I have gravity, which is equal to 9.81 meter per second squared, okay? Then I need this one, okay? Let's rearrange the equation, okay? And you get what? Put this one here. P minus P naught is equal to rho GH. You need this one alone, so divide this one by rho G. This one rho, the other side too. So this one cancels with this one. The equation will be rearranged like this. H, which is the height of the mercury, is equal to P minus P naught divided by what? Divided by rho G. Now guys, look, let's put the numbers that we have. You have 2.7 times 10 to the power of 4, okay? Minus atmospheric pressure. Guys, because it says at the bottom of the mercury, so we are now going to calculate the atmospheric pressure. We're going to just put 0 here, okay? Now it says what? Now we have density of the mercury, which is equal to 3.6 times 10 to the power of 3 times gravity, which is equal to 9.81. Then calculate all of this, and you'll get the height, which is equal to 0.2 meter. This is the height of the mercury inside the beaker. Calculate the depth in the ocean at which the pressure is 3 times the atmospheric pressure. So pressure is equal to 3 times atmospheric pressure. It says 3 times atmospheric pressure. Careful, this is atmospheric pressure, and is equal to what? It is equal to the pressure in the ocean. Calculate what? It says calculate the depth. So depth, we need what? We need H. H is equal to what? Now guys, as you know, that atmospheric pressure is equal to 1.01 times 10 to the power of 5 Pascal. You have density of water, density of seawater, which is equal to 1.025 times 10 to the power of 3 kilogram per cubic meter. And you have gravity too. Gravity is equal to what, guys? Gravity, as usual, we have 9.81 meter per square second. Now guys, it needs what? It needs us to find the height. We're going to use the same equation that we had, guys. Now we will say pressure, absolute pressure, is equal to P naught plus rho GH, okay? Rearrange this equation, put this one here. You have pressure, let's erase this one. You have pressure subtracted by atmospheric pressure, which is equal to rho GH, okay? Then you need to find this one, divide this one by rho G, and divide the other side too by rho G. This one cancels with this one. You have H is equal to pressure subtracted by atmospheric pressure, all divided by density multiplied by gravity, okay? Put in the givens that you have. You have what? H, which is equal to what? Now guys, you had P, which was equal to 3P naught minus P naught, divided by what? Divided by gravity. Okay, sorry, divided by density G. Okay, now density and gravity. Now you can say that 3P naught minus P naught, you have what? You have 2P naught divided by density multiplied by gravity. Then you have 2 times atmospheric pressure, 1.01 times 10 to the power of 5, all divided by what? Divided by the density of seawater, which is equal to 1.025 times 10 to the power of 3, times the gravity, which is equal to 9.81. You have the height, calculate all of this and you will get 20.1 meter. This is the depth of the ocean. Okay, this is practice 3C. See you in the next video. If you have any questions regarding these problems, feel free to ask me in the comment section. See you in the next video.